Tonight, you'll probably eat something cooked without thinking twice about it. It's such a basic part of being human that it barely registers as a choice. But step back for a second. No other animal on Earth cooks its food. Not chimpanzees, not gorillas, not a single one of our closest living relatives. Every other species on this planet eats its meat, its plants, its everything, exactly the way nature hands it to them. So somewhere in our past, something happened that never happened to any other branch of the animal kingdom. One line of primates started putting food into fire, and it changed us so completely that most of us couldn't survive for long eating the way every other animal on Earth still does. So what actually happened and why? The most influential explanation comes from primatologist Richard Wrangham, who published a theory in 1999 that's since reshaped how anthropologists think about human evolution. Wrangham's argument is blunt. Cooking didn't just make food taste better. Cooking is what made us human in the first place. To understand why, you have to understand what raw food actually costs your body. Digestion is expensive. Chewing, breaking down tough fibers, extracting calories from raw muscle tissue or raw plant matter, all of it burns energy and takes time. Chimpanzees, our closest living relatives, spend roughly 6 hours a day just chewing. 6 hours every single day, simply processing food well enough to survive. Modern humans spend, on average, less than an hour. That's not a small difference. That's an entire second workday that disappeared from the human schedule. And it didn't vanish because we got more efficient jaws. It vanished because cooking did most of the digestive work before food ever reached our mouths. Here's the mechanism. Heat breaks down collagen and connective tissue in meat, unwinds tightly coiled proteins, and ruptures the cell walls in starchy plants like tubers and roots. Cooked food is, quite literally, pre-digested. Your gut doesn't have to work nearly as hard to pull calories out of it, which means your body absorbs significantly more usable energy from the same piece of food just by heating it first. Researchers have measured this directly. Cooked meat can deliver up to 30% more usable calories than the identical cut eaten raw, and starchy vegetables show similar, sometimes even larger, gains once cooked. Cooking didn't just make food easier, it made food richer, calorie for calorie, without requiring a single additional bite. And that extra energy had somewhere very specific to go. The human brain is metabolically brutal. It's about 2% of your body weight, but it burns roughly 20% of your total daily energy, an extraordinary cost compared to almost any other organ in any other animal. Wrangham's hypothesis argues this is not a coincidence. Once cooking started delivering a calorie surplus, evolution had fuel available to build and run a bigger brain, something a raw food diet alone likely couldn't have supported at the same population scale. At the same time, because cooked food required less brutal chewing and digestion, the human gut itself could afford to shrink. Compared to other great apes, human intestines are notably shorter relative to body size, and our stomachs are smaller too. That's an organ we could only afford to lose once cooking was doing part of digestion's job for us. Bigger brain, smaller gut. Wrangham calls it the expensive tissue hypothesis. You can't easily afford both a large brain and a large digestive system at the same time. Something had to give, and cooking is what allowed that trade to happen. The fossil evidence lines up strikingly well with this story. Homo erectus appears in the fossil record around 1.9 million years ago, and it's the first hominin species with a noticeably smaller gut, a considerably larger brain than its predecessors, and, critically, smaller teeth built for softer food. Around the same window, the earliest strong evidence for controlled fire use starts showing up at sites like Wonderwerk Cave in South Africa, dated to roughly 1 million years ago, with more contested, possibly older evidence pushing toward 1.5 million years. The timing isn't a perfect, tidy match. Evidence for fire that early is genuinely debated, but the overall pattern, smaller guts, bigger brains, smaller teeth, arriving right around when cooking becomes plausible, is exactly what Wrangham's hypothesis predicts. There's a more direct, almost uncomfortable piece of evidence too. In the early 2000s, Wrangham and colleagues studied modern humans who deliberately try to eat an entirely raw diet, including raw meat and raw starches, out of health or lifestyle conviction. Even with access to blenders, juicers, and modern food processing that no ancient human ever had, committed long-term raw foodists frequently struggle to maintain healthy body weight, and a significant number of women on strict raw diets experience irregular or absent menstrual cycles, a strong physiological sign that their bodies aren't reliably getting enough usable energy. Modern humans, eating modern raw ingredients with modern kitchen tools, still often can't fully thrive without cooked food. That's a striking result for a species that supposedly could always just go back to eating raw if it wanted to. Cooking did more than add calories, though. It solved a second problem entirely: poison. Countless plants that are genuinely nutritious are also mildly to seriously toxic in their raw state, packed with natural compounds specifically evolved to discourage animals from eating them. Cassava root, a staple food for hundreds of millions of people today, contains compounds that release cyanide if it's not properly prepared. Many wild tubers, beans and grains, carry similar raw defenses. Heat breaks these compounds down, unlocking an entire category of otherwise inaccessible or dangerous food sources. Cooking didn't just make existing food better, it opened up food that raw digestion alone would have made too costly or too dangerous to rely on at all. And there's a social layer to this story that's easy to overlook. A cooking fire demands a fixed location and a shared block of time. You can't cook while foraging on the move the way a chimpanzee grabs and eats fruit on the go. That constraint likely pushed early humans toward regular scheduled group meals, built-in daily moments where a group gathered in one place with nothing urgent to do but eat and talk. Some researchers argue this same routine may have reinforced pair bonding and cooperative food sharing between group members in ways that raw, opportunistic, eat it where you find it foraging never could. None of this came free, though. Once human biology adapted to expect cooked food, specifically a smaller gut, weaker jaw muscles, smaller teeth, we became, in a real sense, dependent on fire in a way no other animal on the planet has ever been. Take cooking away entirely, permanently, and modern humans are demonstrably not built to thrive on a fully raw diet. In a way, our raw eating ape relatives simply are. We didn't just gain something when we started cooking. Quietly gave up the fallback option every other species on Earth still has. So tonight, when you eat something cooked without a second thought, you're not just enjoying a convenience. You're running on a trade our ancestors made roughly 2 million years ago, trading a slower gut and a longer chewing schedule for a smaller stomach and a brain that burns through a fifth of your entire daily energy just existing. Every other animal on this planet still eats the way life has always eaten. We're the one species that lit a fire, changed our own biology to match it, and never looked back.